In this video, we'll be attempting on how to measure the speed of sound, where we'll be using this formula, where C equal to the speed of sound and the SI unit is meter per second. F is frequency, where the SI unit is hertz. And lambda is wavelength, where the SI unit is meter. So, by multiplying the frequency and wavelength, theoretically, we'll get the speed of sound. And through our textbook answer, we understand that the speed of sound is 343 meter per second. So today, we will try and attempt to verify whether the speed of sound is it really 343 meter per second. This experiment consists of a function generator where it will generate a 1 kilotone noise, and it will send the noise to a speaker, the Adam A5. The speaker will output 1 kilotone sound, which will be picked up by a microphone, a Shure SM81. We will send both signals to oscilloscope over here. Then we can compare the waveform of the speaker and the microphone. As you can see from the earlier explanation over here, where speed of sound, we can attempt to measure it by getting the frequency and also the wavelength. In this experiment, the speaker will output the sound source and the microphone will try and capture the sound source. So the speaker will output a scope where you will see the signal in channel A, which is the yellow color waveform. The microphone will output a signal which is going to channel B, which is the blue color waveform. This is what both waveforms look like right now. In this case, you can see that both the yellow and the blue waveform, they are in phase, meaning the peak of the yellow and the peak of the blue waveform, they are aligned. Now, we are going to try and shift this microphone backwards. As we are shifting the microphone backwards, what you will see is the blue waveform will actually shift accordingly. So, we will attempt to try and shift the microphone by 1 wavelength. Here goes. As you can observe from the graph, as we are shifting the microphone, the wave in the blue color channel move forward. So at this point, this is 180 degrees out of phase because the peak of the blue is actually at the bottom of the yellow waveform. Let's continue moving. Now, we have shifted the microphone backwards by 1 wavelength, as you can see from the scope over there. Now, if we observe from the microphone stand, the microphone actually moved backwards by 34.5 cm, and this, as we observe from the graph, is 1 wavelength. So taking the parameters from the experiment, the frequency is 1000 Hz, or what we call 1K Hz. The lambda is 345 cm, so if we convert it back to meter, that's 0.345 meter. From that, if we take frequency, multiply with lambda, we will actually get 345 meter per second, which is quite close to the textbook answer of 343 meter per second speed of sound. So I hope that this experiment demonstrates the physical properties of how frequency multiplied with wavelength can actually get the speed of sound, which is 343 meter per second.